Welcome back. So I've discussed the char variable type before. Now in this lesson I want to talk about the characters and the strings again. So we'll talk about those in a bit more detail. We'll introduce the string object and also some of the operations that you can perform on characters and strings. So as a quick recap on the char variable type, a variable to store characters such as 3, Z and T for example, use single quotes. We have an example of a declaration and an initialization syntax. You can assign the character A to some grade symbol for example. Of course, you can use list initialization as well. This is simply using the assignment operator. The type specifier again is char, and then the size or precision is going to be 1 byte, so 8 bits. Again, just a recap on the difference between string literals and character literals. A string literal is within double quotes, a character literal is single quotes. Also, if you try and assign some character B without the single quotes to your character variable, then of course that is incorrect. You want to use the single quotes as I mentioned. But you might be thinking, what happens if we assign some integer? Well, behind the scenes we actually use integer codes or ASCII codes, so numbers to represent those characters. As we'll see in an upcoming example, I'll show you a character and ASCII table where we'll see certain numbers represent certain characters. Also some of the char types, of course, we have signed chars, as you have with integers. Now also mentioned the numbers of bits in a char is going to be 8. Then the maximum value for the char is going to be 127. Remember, a sign type has positive and negative values, so the minimum or negative value is going to be minus 128. You also have an unsigned char. Now remember, we're going to start at 0, so the maximum value for the unsigned char is going to be 255, because as I also discussed before, the number of representable values for a type with 8 bits is going to be 256. So keep this in mind when we look at the ASCII table next. The values go from 0 to 127 for those codes, but you also have an extended table where the codes can go from 0 to 255. You can search a web browser for an ASCII character set or an ASCII table. Now ASCII stands for American Standard Code for Information Interchange. Our chars or characters basically store an ASCII code that is going to be a representation of a character, because remember, the computer can only understand numbers, so it doesn't store the character itself, it has to store the numerical representation of that character. And so with that we can reference an ASCII table to get the numerical representation of those characters. So for example, you can scroll down here and for example, let's say we go to X. The decimal representation of that is 88. So that is the ASCII code for that. Of course, you also have octal, binary and so on, but we are concerned with the decimal here. Then I'd also like to mention, if I scroll down a bit, you also have extended ASCII codes. You can see this starts at 0. If you scroll up, that is the null character. And then with the extended table, you also have a bunch of interesting codes that you can do ASCII artwork with, for example, so you can make a loading bar and so forth. So you have a few more characters to work with. This is the table that I'll be using for this example, but again, you can go and search Google or something for a different table if you want. And I'll just go here to this Wikipedia page. Just out of interest, you can see some of the ASCII art, and I'll link you to this page if you want to give it a read. All sorts of interesting things that you can do, funny things like this, for example. Alright, I'll switch over to Visual Studio now, and we've covered characters before, so we can store some character in my character, okay, that is of type char, and I can print that out, as you can do with an int and so on. And I'll just build and run that, and we should get X printed out. Now what I can do is I'll copy this line here, and then I'll set my char to something else. Now let's say we want to store Y in that, something like this. Now of course this will work. I'll just build and run, and we get X and Y printed out. I'll bring up that table again. So the decimal code for X is going to be 88, and the decimal code for Y, uppercase, you have lowercase as well. To the right we have lowercase as well. So lowercase for X, for example, is 120. Let's start with that. Instead of storing the particular character, I can assign it to the ASCII code. That was 120, and now this line should print out lowercase x. Build and run, and we should get uppercase X printed out in the first statement and lowercase x in the second. And also, as I mentioned, 89 represents the uppercase Y. So if I build and run with this, you see we get Y. Next, let's say we want to print out what the code is that is stored in the character. Pause the video for a second as an exercise and think about how we can get the actual code the ANSI code that is stored within the character now. How can we print that out? So first we are going to print out what the character actually is, or what that code represents, and then we actually want to print out the code itself. Okay, so I'll move on here, and of course what we want to do is we want to convert that character to an int. So you can do it in that way, that should work fine. We should get 88. If I build a run, let's see if that works. We get 88, that works. You can also do the static cast, build a run, and that works fine. You can see we get 88. You can also try and use some of those codes from the extended table. For example, comment that out and build a run, and you'll see we get X and then that character now. Or something like 220. Now not all of the characters will always match, you have to sort of look at what you have, and sometimes the extended table is different, so you get characters that you do not expect. 242 for example, that's going to be a bit different. But notice once we try and use characters from the extended table, we will get a warning, a truncation warning. Now if you remember, a signed char can store 256 values, but it has positive and negative values, so the positive range again is from 0 to 127. So you can think for a second, how can we get rid of this annoying warning right here? Well, what we can do is, we can make this an unsigned char, and then that warning should go away. So I'll just build and run again, because now it's only going to store positive values, so 0 to 255, and we don't get any warnings anymore. With that, we are going to wrap up this lecture. You should have a better understanding of characters at this point. And in upcoming lectures, I want to talk about strings again, which is basically character strings or character containers. Alright, so I'll see you next time.